Hey, hi guys, good morning. Yeah, let me start sharing my screen. So, did you all get chance to go through your assignments? So, what did I give? Before I start with today's session, do you have any questions on the topic that we have discussed so far? I think this one we have already covered. If not, not right now. Okay. Yeah, this is one another cheat sheet PDF that you can refer in case if you're coding anything in Pig. So you can refer the data types, all the data types, int, long, float, byte array, boolean, even date, time are also added into this. Okay. Tuple, bag, map, and diagnostic operators are the debugging commands. So describe, dump, explain, illustrate. We have discussed about each of them. And relational operators like co-group, cross-product, and cube, we didn't see. Anyway, it's same as your SQL cube, but even I didn't use that much. So distinct to remove the duplicates, filter same as your where condition. Okay, flatten for unnesting a bag or a tuple, and group all and group by one column. So inner joins, equi-joins, and these are outer joins. There is one more join type called replicated, and this will be useful, efficient when we have at least one table as small. So if you observe here, one of the best standard or one of the best practices is that, so if you are doing any inner join or outer join, it is always as a standard to keep the larger table on to the rightmost. Okay, so if I have two tables, left table, smaller table will be kept left side and larger table will be kept right side. That way, it will never try to put the larger table, the rightmost side tables into memory. It will not keep. Okay. So this way, larger tables, you have to keep it right side. But in case of replicated joins, so when you have one or more relations are small enough to fit into main memory, then only you need to go for replicated joins. And we specify this using replicate. So this is the extra clause that we specify. And here in this case, the larger tables will be specified on left side and the smaller tables will be kept on right side near join state. So limit, same, and load data using different load operators. Order for sorting them, sample to take a sample, and to split your data into multiple relations based on a condition. You can use this and store your bag results into a directory. You can use that. Union also we have seen. And in generate, this is like by positional notation accessing the fields. Generate $0, $2 means first field and field 3. And if you have a sequence of fields, you can specify the dot also. So field 2 dot field 4, then field 2, field 3, field 4 are included. They are in a sequence. Okay, and similarly field 2 dot, so it will be included till the end of from this field onwards. Generate star means it's star. Select star. All these are very simple. So we didn't discuss about the UDFs. Let's go through now. So these are some of the mathematical functions. After that, some evaluate functions are. Okay. So average of column, concatenation of 2 strings, count of a bag, and count star computes the number of elements in a bag, including the null values. Okay. So this count will not include the null values, and count star will include the null also. Diff we have seen, is empty also we have seen. Max, min, and size we have seen. Define anyway we will see now and in UDFs. So size, it gives the size of the string or numeric value. So subtract, tokenize. So some of the string functions like equals, ignore, case matching, comparing, index of, and lowercase first, lower, ltrim, regular expression, extract. So this is like searching for a string pattern in another string. This is my source string, and here you can specify your regular expression and from what is your starting index. From there onwards, it keeps on searching and gives you results the back. And replace and right trim, ltrim or complete trim. Substring, and here are some of the date time functions. Out of these, current time will be most frequently used. Okay. So to date, to Unix time, bag and tuple functions. Yeah. So this is of my important. So here, if you have a text file and column names, if it is a common delimiter like comma, pipe, or colon or anything, then we were using the pig storage, right? And in case if you have a log files, Apache formatted common log loader. Okay, so then we have from pig load store functions, or we can also call this as like all these functions are present in piggy bank. Piggy bank is something that all pig users whoever uses the pig, they might write some user-defined functions, their own functions. Okay, so all those functions stored in a one single jar, and that jar is named as piggybank.jar. Okay, all pig users community providing their user-defined functions into one common jar that is called as piggybank or piggybank.jar file. So inside that, you will be able to find all the custom load store functions that you require. So that's the reason where we might not need a chance for, where we might not get a requirement for writing a new load store functions, like so custom input output formats that we were need to write in MapReduce. So those stuff we don't need to write in Pig, because mostly you'll find everything in that itself. So this common log loader, instead of using Pig storage, is specify using common log loader. Okay, so I don't have this example in this, but we have in our blog. So how to read in a log files using Pig. And how to specify the regular expressions also, you can see somewhere.
Sure.
Yes, is this Lakshman?
Satish.
Yes, Satish.
So the custom UDFs are also based in the Piggy.
What is it? Your voice is breaking, Satish.
Custom UDFs.
Huh.
These are stored in this piggy bank jar.
Yes. Any Pig users, Pig community users, if they add their custom functions to Piggy Bank, they will be available in that jar. Okay. Okay. So I can show you that jar that will be present in your Pig libraries. So user lib Pig, and somewhere, yeah, here you can see piggybank.jar. And if you open it with Archive Manager, you will be able to see lots and lots of user-defined functions, custom functions, piggybank. These are all related to storage. If you want to handle how to load your CSV files, so you have either CSV loader or CSV Excel storage. This is the one which we use mostly. And if you want to directly read in from a DB, so RDBMS, so you can use this DB storage, but this is very less frequently used. The reason is we use a scoop to get the data into HDFS first, and then we can process this as a regular HDFS file in Pig. Okay. And Hive columnar storage, if you want to load from Hive, or we have, we should have hcat storer, that one also. So Hive RC input format. So if you have RC files, record columnar files, those can be loaded with Hive RC input format class. And Avro files, you can use this stuff, but all these are like outdated file formats. Okay, so you don't find them being used much in real time these days, at least. Okay, so in log files, you will again have two types of log files from Apache. So one is a common log loader, and the other one is the combined log loader. So we'll see all those things there. So these are related to load store, and these are here all evaluation functions. Okay. So is double, is float. If a string is given, you want to check whether it's a double or not, whether it's a float or not. So you have given the, by default they are not present in your default Pig functions, but Pig users created these functions and provided them to us in this jars. So similarly, you can see, so to back and strings. So strings also last index of length, lower. So all these are available from there only. Okay. So uppercase first, upper, trim, substring, split. All these functions are not provided by the default Pig framework. Okay. So Pig users has given us these functions in the piggy bank. The same way, all your math functions and date time functions. Okay, so here, one of the intention to show this PDF is that to tell you that apart from Pig storage, apart from bin storage, so we have few others also. So some of them are like, in case if you are processing the log files. So log files will mainly have, so two types. One is a common log file formats, and second one is a combined log files. For common log files, you will have your log messages in this format. Like, so the first qualifier will be, the first field will be either host name or the IP address, and second one will be log name. So here, in case in this example record, I have hyphen. So third one is username, even that is also hyphen here, and fourth one is a time, and fifth one is the status code. Fifth one is the fifth one is the request, and sixth and seventh one are status codes and bytes. Like I have given you some sample common access log files attached also to this. So this is one of the let's take one record. Okay. So if I take some record, so this is the IP address from which the request has made, and this is from another IP address. So the username and the login name, I think. So capture the date and time when this request was received. Okay. And whether this is a get request or post request or put request, especially in web pages, those are the four types of requests that you see: get, put, post, and delete, right? And get request to this URL, and status code 200 means in terms of web pages, so it's a success code. And how many bytes transferred? So these many. And here, so if you see here, so he's trying to access this page. So status code 401 means page not found. How many bytes transferred during that request? So the page not found message, or that page got displayed back. So even for that, some bytes needs to get transferred. So this is your common access log. Okay, but this is also not being widely used these days. And we have combined log loader with 2 extra parameters to this common log loader. Okay. So in this, in combined log format, so hostname, log name, username, and time, request, and status code, and bytes. Till here it's common. So the next one is who is the referrer and who is the agent. These 2 extra fields will be there in combined access log. If you observe this one, this is one of the real-time log file of our blog itself, Hadoop tutorial.info. So this is the IP address that I received a request from, and the user log name, username, and date and time. Okay, and it's a GET request for category Flume. On category Flume, someone clicked and they got the response status code as 200, which is success, and they got these many bytes transferred. And the page that they have accessed is this, the one. So Hadoop tutorial.info, Flume data collection into HBase. And it is from Mozilla 5.0. So all this information, agent information. So with this, so in order to process this file, I have the combined log loader, and I will show you the example usage of that. So load the path of my combined log loader. You can see. So load the path of the log file using, instead of pig storage, I specify the combined log loader, arg.apache. The complete full class name of it. Okay, so combined log loader as, so you want each of them as a different column names, right? So first one is IP address, char array, which is a string. Second one is a log name, again another string, which is char array. So username, which is char array, time is char array. So what type of request? It's a GET or POST. So that method, and URI. So that one. So inside that prototype char array, status code, it's a 200, 401, how many bytes transferred, referrer, user agent. Okay. So in this, so it will get, by looking at this file, it will map from every record. It will map, where is this? So it will map the user IP address, log name, and username, and this date and time. The next one is, if you check here, so this is if the get or put, that will be captured into this method. Okay, so after time, and URI, this is the URI that they access, and prototype, which protocol this is, like HTTP or something else, and status 200 into that, number of bytes into that, into this field, and referrer, this entire URL into this, and user agent, whether it's a Mozilla, Chrome or something, you can get all these fields. Now this is like a table with these many columns. Now if I want you to do, give me the count from each IP address, so that, so I can get the statistics like how many unique visitors visited my website today. Then I can take that entire day's log files and I can get the distinct count of your IP address. That is the unique list of visitors that visited our site. And the next parameter is like each visitor, how many page views. So count of group by your IP address and then get the count. Okay, so you can see here group logs by referrer. So this is like for each page, what is the total count of page views? So in this script, I'm trying to do that. So referrer is nothing but the URL. This is the URL, right? So after status code bytes, number of bytes, I have reference. This is the URL. This is my home page. So if I group that by referrer and refer counts equal to for each reference, generate pattern of $0, which is first field, and referrer, and count of $1 as count. And the order referrer counts by count descending order. This way, the topmost counts will come first and the lower ones will come later. So if I limit this sorted output, so I can see the top 10 pages that got the highest number of page views. Okay. So if you have, whenever you find some time, so do that.
Hey, Ishu, I have a question for you.
Yes.
Yeah, is the log file pretty standard here? I mean, because we are using the common.
Standard. See, common combined log files, that format is pretty common, standard across all the websites. So
I see. Okay.
if you take any website, it could be any website. They produce in the web servers, they produce the log files in the same format.
Right.
Why we call this as, it is not something that we define this format. This is called as Apache Common Log Loader or Apache Combined Log Files. Apache.
But doesn't it depend on the web server we use, or is pretty common across all the?
Yep, it is not depending on the web server. It is pretty common across all the website log file formats. Okay.
Oh, thanks.
So now you have those as a standards, but if you ever observe your Hadoop logs, they won't be in that format. So when you have some custom log files, if you don't find in that format, then how do you extract them? So
Okay.
Yep. So we have, instead of common log loader or combined log loader, we have my regex loader based on the regular expression you provide. So it will parse your files. So if you observe here, Hadoop logs. So this is not in that format, right? If you check here, so this is some date and time followed by some number, some, whether it's info or error or warning message, and following after that the actual message. So this is the pattern here. So if I want to extract only such records, and from my Hadoop log messages, if I want to extract how many severe error messages are there and what are they. Okay, so you can see this sample extract error message. So I'm grouping by type, which is info or warning or error messages, and so getting the counts of them for each info, error and all, and storing counts somewhere. And again, if I have interest to only to extract either warning or error messages, I will be filtering them out and storing this error or warning messages into some location. So here, so one simple example of providing the regular expression. So this is something like a general topic that is needed for even for Java programmers or Scala programmers, or it could be any language. So regular expressions are a common topic. So I hope you should have a basic idea on this. Okay. So if not, I can explain you the bare minimum, but beyond that, if you want to understand, you should explore or you should do Google on this. Okay. So here, if I want to extract the date and time, so backslash, so 2 backslashes. The first one is for format escape sequence. The control, this control symbol is for to denote that your line is getting started, and dollar is to denote your line ends. This is line starts and this is line ends. So parenthesis open and slash slash. Okay. So this backward slash backslash, 2 backslashes, 1 backslash D is to denote the digit, and this second, the prefixing backslash is a format escape sequence. Okay, so this means you are expecting in the beginning of the line itself, you are expecting 4 digits. After that, 1 hyphen, so this one. After that, you are expecting again 2 digits. After that, you are expecting hyphen. So let me show you this file as well. Then you can compare this with that. See, in the beginning itself, I'm expecting 4 digits, which is for a year, and hyphen 2 digits, that is for month, and hyphen 2 digits for date. So after that, backslash s plus. Backslash small s means, backslash small d means a digit. Backslash small s means space. After I receive this date, I should have at least 1 space. So that's why I used s plus. If there can be 0 or more spaces, then I should use star. Star is for 0 or more occurrences, and plus is for at least 1 occurrence. And immediately after that, again I have the date, hours, 2 digits, dot or colon, you can specify. Dot is for any special character. Okay, so it's not just for the dot and a colon or something. So this is the minutes, this is the seconds. After that, so whatever this milli UDF or some time zone or something. So again, after that space followed by capital S means non-space. Small s is for space, capital S is for non-space, and small d is for digit, capital D is for non-digit. Same way. So after time, I'm expecting some space. After that, some non-space value. This will be into your third field. And again, after that, some space. And you are expecting the rest of the thing into fourth field. And again, if you have a space, and following after that dot star, anything into fifth field. So here this is the first part, date, and second part is time, and third field is my type of the error message. So you can see the same I have specified in the schema as dt is the first field, and time is the second field, and type is the third field, and class. So what is the class that generating this is error message? So this one, whether it's a name node or something, that. And at the end, so the actual message. Like if you have warning message, so till here is the class that generates this warning message. Then here is the actual error message saying that home user downloads big data and then should be specified as a URI in configuration files. Please update HDFS configuration. So this way you can extract all your warning messages and all your error messages into a separate report and can see what are the classes that are generating these messages and what is the problem. You can check the health status of your cluster. Okay. So obviously we don't use this much of tedious process to do the health status check in real time for Hadoop cluster. We use Cloudera Manager or the Ambari to do that. But so I'm trying to show you the low levels that you can achieve this as well with different load store functions. Okay, so those are log file formats, common log format and combined log loader, both are available. And in case if you have any data in Excel sheets and if you want to directly load them, yes, you can use the CSV Excel storage. And this DynamoDB is one type of database. Greenplum is to interact with your PostgreSQL. And fixed width loader is not much widely used. Hive columnar loader also not. Yeah, and when you have any file in JSON format, you can use the JSON loader. I think we already talked about that. And if you have data in MongoDB, and if you want to load that, so you can use this load. And if you want to specify the schema also, you can specify here. And pig storage we have seen, and DB storage for any RDBMS. I think it should work for all RDBMSs. For XML files, you can specify that. So it's just a matter of one line of code. You specify there. This is the one line, that's it. It parses your input file and it gives you in this format, like in these columns. So following after that line, so you can use any of your typical pig commands. Okay, so these comparisons also we have seen. So when you get time, go through this. So those are some of the string functions and all. Okay, so that's it. It's just a quick revision and to highlight that there are other load storers also available in piggy bank and to get you introduced into the piggy bank. Okay. So next, let me start with the actual today's session. In case if you want to write any of the user defined functions from your end, so you can specify the so we'll go through those user defined functions now. And after that we'll discuss the pig optimization techniques. Okay. So you have seen some built-in functions, some pig built-in functions, and some of the custom functions that you received from the piggy bank. And so similar to those, if you want to provide anything or if you want to write anything, so the way we have seen here. Okay. So here, so one of the functions like, so in strings, if you check there, so upper is 1, UDF, user defined function. This is not the default one that shipped with your Pig distribution, but this is because of Pig users generated this. And first uppercase, first character, trim, and substring, all these are user defined functions. In case if you have to write it from your own, okay, if you know how to write these, at least this existing function, and if you have anything that if you have to write newly into your user defined functions, so you can write it. Okay, we'll see that procedure. So we can also write the load storer functions also, but so in my opinion, you'll never get that requirement because your piggy bank has a wider range of all the load storer functions. It can handle JSON files, it can handle log files, it can handle. We have seen those, at least the function names. Okay, so the example usage for some of them. So it can directly read in your RDBMS, it can read in XML files, it can read in JSON files, it can read in your CSV Excel sheets. Okay, so that solves almost all the purposes. I have given you the load storers for ORC format also, but we didn't discuss much about that. So once we discuss the file formats thoroughly, you can use that syntax. And I have given you an example to load data from your HBase also. Okay, so using the HBase storage handler, so reading data from HBase, reading data from ORC, reading data from Hive, everything in real time, whatever you get the requirement. So they all are present in your piggy bank itself. Okay, but there are some scenarios where you might need to go for some eval functions or some filter functions. Okay, so let's see these two types of user-defined functions, keeping the load store user-defined functions aside. Okay, so eval function is something that any operation that you perform, like, and you always mix that with for each generate, like you can use only in the select classes, this user-defined functions. Here for each generate, the UDF that you write and pass in the column on which column you want to perform that UDF. And these eval functions expect input as a tuple, input comes as a tuple, and these should extend the eval function of generic type, this interface. And in the implementation part, we should initially we should check for the empty or nulls in the input. If it is empty or nulls, we should return the empty or null value. And we must provide the implementation for one of the exact function, and we should return the values. And get argument to function mapping, output schema. These are the additional two methods that will be present in this eval function interface or the UDF class. We'll see. These are like the optional ones, but I will tell you the importance of these two functions as well. But we'll see the bare minimum UDF how to write.
So, Ishu, I have a question here. Does it have to be Java, or we can use Python also, right?
You can use Python also.
But what is it commonly used? Is it Java?
It's Java.
Yeah, okay.
Because Pig itself is written in Java, and it has more integrity with Java language.
Okay, thanks. Yeah.
Okay. Yeah, but you guys, Lakshman, I mean, since you are from Python background, you can give it a try. You will find some examples very easily, I think.
Yeah. Okay. Okay. Yeah.
Yeah, but I'm not a Python guy or a Python expert, so I don't have an idea on that. Okay.
Yeah, that's what I think. Yeah.
So if you see here, so simple, the same uppercase UDF that is present in the piggy bank, if we have to write from our side, so this upper or any of these, okay. So the procedure, let's see. So I imported from pig libraries, pig packages, arg.apache.pig.eval function, and tuple class in this class. So public class upper extends eval function and which expects a string as and which acts on strings like okay. So public string exec tuple input. So if you pass that tuple, that entire record, okay. So throws IO exception. It can throw an IO exception because to handle the exception. If input is null or input.size is 0, then return null. There is nothing to convert into uppercase if input itself is null. So otherwise, try string str equal to, so input.get of 0. So my input is a tuple, and inside that I can access each of the fields using get of the positional notation. Get of 0 means the first field. So if you pass a tuple and if it is having 3 fields, if you want to access the first field, you can use get of 0, second field get of 1, third field get of 2. If you pass only one field, then we can specify the get of 0. Okay. So input from tuple.get of 0, I get that field into this string str. Now in Java we have lots and lots of methods to perform your string operations. All this entire string functions UDF you can write in just 1 or 2 hours of time. Okay. And you can generate all these UDFs if you want to generate it from your end. Okay. So I have received that into string, and in Java I have string.to uppercase method. So this will convert that into uppercase, and that value I'm returning. In case in between if something happens, exception arises, I'm printing that stack trace and returning null. So this is for uppercase. Now to convert the first character as uppercase, you can similarly find in Java methods on strings. And if you want to trim, you can call str.trim, then that will become trim UDF. If you want to reverse, you could have called the reverse. And if you want to have a lower, you could have called lower. If you want length, you could have called the length. If you want to call index of, you could have called index of the Java. See, Java is a rich set of API it is having on each of the data types or something, whatever. So we are trying to leverage those Java Java features into Pig. Okay. So by calling that Java's to uppercase, Java's string, Java's length, or Java's lowercase, those methods, we are able to get the same features in Pig language as well. Or if you have any custom logic, yes, you can implement that logic also. Instead of calling the existing Java methods, you can write your own Java logic and convert them into whatever format you want and return that value. So once you write this Java code, we'll see where to write this and how to build a jar file and how to register your pig engine, how to register it with your pig engine, and how to make use of this upper UDF.
Siva?
Yes, Srinivas.
No, this is Anand Siva.
Yes, Anand.
Siva.
Yep.
So, can you quickly narrate, like, what examples, because we can use functions, right? Why do we have to use a user-defined?
If you don't have the built-in function, by default, in your pig, you don't have the upper function. You have it in your pig grunt shell. The reason because somebody has given you in the piggybank.jar.
Oh, but we cannot get it from the web, like, piggyback.
Piggybank, you can get it from the web. You don't even need to do that. It's already part of your user lib pig directory. So what I'm trying to show here is that, let's say you have this limited list of functions here.
Okay.
Index of upper this many. So what if you want anything beyond this list?
So for that we'll have to go to custom.
Yep.
And online we are not available, right? Online, all the...
If they are available, you can go directly, get the source code and get the compile, everything done. Mostly 95% of the scenarios, you may find it in online. Okay. So in case if you don't find anywhere, and if you are okay to write in Java, okay. I mean, if it is simple logic, or if it is fair enough to write it in Java, you can write in Java and use that in pig. That is what I'm trying to show here.
Okay, got it. Makes sense. Perfect. Okay.
Okay. So now, assuming that this upper is this piggybank.jar is not there, or this, I am going to write my own upper UDF. Okay. So I will give you one UDF as assignment for you after today's session. So that should take a date in a format and convert into one unique format. That is one of the real-time UDF that we see. Okay. So that example I will give you for your assignment. You can use the simple date format or any Java API. So in Java, you have a simple date format classes. So let me explain that assignment once after I complete this example. Okay. So I have defined a public class test UDF, extending this eval function. So check in the exec method, I verified input null or size is 0. If it is null or 0, then I'm returning null. Otherwise, I'm casting that into string, because you will get this as a char array and casting that into string, and that string is calling the Java method to uppercase. That's it. It's just a matter of one line of code that you write inside this. Okay. So here, since you are using pig eval function and pig data tuple, so you should have some of the pig jars. Those pig jars, you should have them here, as I was showing you for jar and MapReduce. So similarly, here you should refer to user lib pig directory and load all these pig jars. Okay. So pig and pig cdh, whatever these jars that you find here, so you include them. All of them are not mandatory, but at least the pig jar is needed. So you should include that. Okay. So once you include, you'll be able to compile it. And if you export it as a jar, just jar. So let me name it as Pig UDF. Okay. Now this jar file. Now I should register that jar with my pig engine. So for registering, we have register command and specify the path of your jar file. It's present in /home/cloudera on my home directory, pig UDF 3.jar. Let me take the path of it. Okay, so this jar got registered now. No errors this time. Now we can define a function name to that. You can give an alias name to it using the define method. So at least you should be good at understanding these steps. Okay, so define. So I define to upper is my function name. Okay, so I should provide the class name, fully qualified class name. This is my class name, test UDF. My alias name, my function name that I am going to use inside pig engine is this is the one. Define this as this one. I think I should use as also. No, okay, fine. So that is defined. Now, if I want to convert anything into uppercase, let's say if I have word count, this to upper. So in our previous example, we have seen in word count example, I was generating this group means word count, this is the word, and count means its corresponding count, right? So since these are words and strings, if I try to convert this into uppercase, let's see whether we'll get all of them in uppercase or not. See, I was able to register my UDF successfully and define an alias for that. And I used that in my for each generate, and I made all my words as uppercase. Okay. So this is the function that I defined, right? So just to recap the steps inside that, first you need to write a class extends eval function of data type you should specify there, and you should provide the implementation for the exec method, and this expects a tuple, so one tuple as input. So exec tuple, inside that you do the basic checking. If it is nulls, return null. If it is having some value, so whatever the operation that you want to do on that values, you can perform there. And once you complete this Java code, make it export as a jar. Export as jar. And this is the second step. And third step, register jar and pig, and define a function for the class name, for the pig class name. And fifth one, use that for each generate. For each generate statements only, we use this. Okay. Next, we'll see. We'll see some of the filter functions as well. So similar to eval functions, filter function is something like checking a field for a value and returning a Boolean value, whether it's equal or not, matching or not. Okay. So extends.
Shiva, sorry to interrupt you, Shiva. Can you go to the Java? Can you please go to the Java code? The page which shows the Java code.
Yep.
No, not here. In the presentation itself.
Okay.
Yeah. Yeah. Sorry, this is good. So here we're extending the class, but I was expecting some method here. There's no need of method here.
It's there. Public string exec is the method.
Oh, so exec pig understands that anything inside exec is you're going to execute that part, is it?
Yep. Yep.
Oh, okay, got it. Okay, so that's why you're registering only the class,
yep.
So that exec. Okay, got it. Thanks.
Yep. Okay. And similar to eval functions, we have filter functions as well, and which in turn extends a eval function, and your filter functions always return a Boolean value, true or false. Should check for empty or nulls in input. Like you may write one filter function which checks for a particular set of columns and verify whether they are null or not. So if you want to check for the entire record, if it's a dummy record or not, and if you have columns like here, pig assignment, let me add something. So now using that eval functions, I want you to write. So take your sample file, sample input file with just 3 columns. Okay. So name, address, and date. Okay. So name, address, and date. So here, write a UDF to convert, and date you will get from your input file. You will get in this format. So 2016/06/20. So in this format you will get. Okay. And I want you to write a UDF to convert the date into your standard format in your enterprise organization. You store this in YYY space space DD. Or if it is a string, or I want you to convert this into MMDD YYY format. No spaces and no slashes. The first month should come first, date, and then year. So I want you to convert this in this format. So hint, you can use a simple date format class. Right here you have to convert the date into this format. Okay, so try this. So I've shown you an example on string. I want you to work on date. Take this date. So this is one of the common UDF that we might write in real-time scenarios, because from different sources you will get dates in different format. So in India you will find DDMMYYYY format. In US it will be MMDDYYY format. But when you are storing the data into one single database, you obviously need to convert them into one unique format. So assuming this is the unique format, I'm asking you to handle just only one format into this format. But in real time, we'll convert all the formats into this one format. But try with this, converting this into this format. Register the jar and run that in big script and show the results. Okay, so this is one thing. So filter function, yep. So using this, so one we can say whether we can identify whether it has a bad record or good records. So let's assume your name is null. So in the same example, write a filter function. Write a filter function to identify bad record. Okay. So for identifying bad record, in my business rules, I have name should not start with special character. Name should not start with special character. Like you take only this list, hash and dollar and ampersand. Take only these three characters. Your name should not start with these. And similarly, the address also. So name and address should not start with special character. If it starts with special character, then you should mark it as a bad record. You should return it as a bad record. Then I will use in my filter conditions. So hint is like you will write the same, similar to your filter function, eval functions that we have seen. So here instead of eval function, you use filter function of, okay. And we need to import that as well. It's already imported, right? So filter function is not generic. It can be parameterized with the arguments of string. Okay. So here you should return only Boolean from this. Okay. Let's see that true or false. Return false. And here you should write your if-else conditions, like if string dot first character. How to get the first character? You use any of your Java methods. Str dot get caret 0, caret of 0 to get the first character. Char ch equal to this one. Okay. So here you should get both the strings, like so input dot get of 0 into the first, which is a name, and second field is address. Okay. And you should get the first name ch, first character, and name character, and similarly you should get the address character. Okay, and now check if name ch equals to, or start name ch equals to hash, or again name ch equals to, so all the special characters. Okay. So, or the other condition is and address ch equals to hash dollar or that, then return true. Return true. And name this class as is bad record. Okay. So only if the name or address starts with any of these characters, then we are returning true. In all other cases, it's false. Okay. So now, if you use this and if you pass those two fields into calling this method, okay, so you can either, or you can restrict yourself to pass only just checking the name itself. Okay, even if you want to stop that. It's up to your wish. Okay. So just work it out on one field or two field. It's up to your wish. But I want this. I have shown you almost all the code. Then register the jar and run that in your pig shell. Show me the results. Okay. So this time it's a filter function by extending the, and if you checked it or not, I'm not sure. I have already given the examples in the Google Drive for you. In the examples with source code under pig, have given you all these pig scripts and the UDFs also. In the source code, you can check in this packages. So I have some filter functions also, examples. Now, you can use this as a reference, same exec Boolean exec tuple input. So it gets the first field. If the source contains, so my source string contains twit VM, then I am returning true, otherwise false. It is just to check whether my input string or input line contains this twit VM or not. So to identify whether it's from VIM or not. So I'm just checking for a string equality. If it finds, it will get true. Otherwise, it will be false. So here, the purpose of showing this example is the other two methods that I was talking, right? So get argument to function mapping. Okay, so don't get surprised or don't get, don't take it as complex. It is just a skeleton. Okay, so once you have a skeleton available in any of your filter function, you can use it anywhere in any of your own filter functions. But you should understand the purpose of it. The purpose of it is to, so here you know that inside your Java, you are performing a string operations on the column that you passed. So what if you pass a numerical column to this and you may get some number format exception or string null pointer exceptions in Java. So to avoid that scenarios and to enforce that you are expecting a string as a parameter. So in order to enforce you to provide only the string type of columns to it, not the integer, not the float, not other types. It is just to enforce the data types. Okay. So forget if you're not from Java background, you can take this as just a template and provide your data type in this. What is the data type that you are expecting here? If it is one field, you'll specify data type dot char array. If it's multiple fields, you will repeat the same. If it's multiple fields, you'll specify. If it's a float, second field should be float. You are doing that field. If you are using this field in some arithmetic operation, and if you pass a string, you'll obviously get number format exceptions. So to avoid such scenarios, we should enforce that I always expect first field as a string and second field as a float. Okay, so this is the only place that we specify the data type at the time of writing your function itself. Once you register this, and if you call that for each generate or something with some integer column, then it throws you that time itself the error message that it expects a char array. Okay, so this is going bit more advanced into your user-defined functions and enforcing the data type. Okay, this is up to your wish. Just first, for now, try practicing only with the exec method once you understand the purpose of it, and then you can go for this is anyway optional. It's not always mandatory. If you get some exception, anyway, you'll come to know that you're passing. But that is a different scenario. If you want to go advanced, you can use this one also. Okay, so that's it all about the two types of user-defined functions. Okay, and there are a couple of more user-defined functions in that source code folder that I shared in the Google Drive. So get return names and strip code. So you try to understand those on your own. Okay. Now let me move on to pig optimization. best practices or standards. So these, just the heading and the examples will make you understanding better. Reduce your operator pipeline. So what does that mean by is, try to reduce your big statements as much as possible. Don't create too many aliases. Okay. So if you see here, I have some sample map.txt file, and inside that have two keys, K1 and K2. Okay. And so in this first statement, I'm loading that. In second statement, generate in hash K1. In is the column name, and inside that K1 value, I'm trying to get as K1, and in hash K2 as K2. So, but this is not my final intention. I'm getting the K1 value and K2 value. Finally, I need that concatenated value as output. So C for each B, generate concat of K1, K2. So now, instead of writing two for each statements here, one for generating the values and the other one concatenate, so we can merge them into one for each. For each A, generate concat of in hash K1 and in hash K2 directly here itself. Even now, within the B alias itself, you will get the concatenated result. So combining the two for each statements into one will improve the query performance. No need of calculating the intermediate alias. This B and then C. And second best practice is that use the data types. So while loading your file, let's say I have data.txt file, and use specified pig storage comma and as TUV. I specified only the column names. But if I don't specify the data type, by default they will be byte arrays. And whenever you say for each A, generate T plus U, so this is an arithmetic operation. So then it will convert this T from byte array to integer or float, and U also to integer or float. So that implicit conversion will takes place. But for that implicit conversions to take place, it takes a fraction of seconds, which again, an extra overhead on your pig engine. So instead of giving that overhead, so if you specify the data types at the time of loading itself, then that implicit conversions will not happen. And it improves your performance. Agreed? So that's the second best practice. And third one, project early and often, as often as possible. Okay. Under this, again with example, you will be better able to understand. So I have data.txt file and content.txt file. So in this, I have three columns, T, U, V, and in this X, Y, Z. And I'm joining them. So each of them A by T and B by X. And finally, grouping the joined result by U. Okay. So by U, I'm grouping them. And finally, for each D, generate group comma means U comma count of $1. So here, I'm trying to get the counts of U's. How many times that is repeated. If that is my intent, so what is the need for passing V and Z throughout this chain of commands. So we'll eliminate them. Okay. So I loaded this file tuv. So at the time of specifying, at the time of loading, you should specify all the columns. And then immediately after that, a1 equal to, for each a, generate only t comma u. I don't want v. So t comma u is only extracted into a1. And into b, I have loaded xyz. But here, I need only the x. If you observe, I'm using only t, x, and u in these operations. So I generate only x. So 2 columns has gone. That means 66% of data has gone. Only 33% is data you are getting here. And here only 66%. So instead of total 6 columns, you got only 2 from here and 1 from here. And now if you join, so in join operation, you have less data now this time. Your data got reduced to half. So join a by t and b1 by x. And for each c, generate t comma u. And even after joining, I don't need the x. I just need t comma u and generated the group by u. At least I need one extra column along with u. So that's why I used t comma u. And group c1 by u and generate group comma count of dollar. Even this will also give the same. So here you will see more number of lines of code, but you are reducing the data that gets transferred across the join and after the subsequent steps. Join and group by statements. So does it make sense? So reducing the data transfer through the chain of operations obviously improves the performance. Okay, and filter early and often. That is, projection means filtering of your columns. Here filter means filtering of your rows. Okay, I loaded the same 2 files and perform the same operation. After grouping them, I want to get only the records with that group count is 1. Okay, so filter e by c dot t equal to double equals to 1. Then, so instead of filtering these records after performing the joins, I could have filtered in the a itself where t is 1. Filter a by t equal to 1. And limiting columns only to x comma y, t comma x, and group by u and generate. Even this will. So now, before the join and group operations itself, let's say if there are only 10 records that matches this t equal to 1 condition, then you will be using only 10 records in the join operation. Whereas without filtering, if you had 100 records, then all the 100 records has to go through this chain of commands. This is more like your SQL optimization in the early days of Oracle or something. But these days you don't need to worry about that optimization. Oracle does for us. Okay. And especially in case of joins, dropping nulls before join is more recommended. Tends to less transfer of data. Transferring data will be reduced. Okay. And in the joins optimization part, as I was already highlighting in the Pig Motors cheat sheet, we always need to keep the larger table on right side and smaller tables on left side. Okay. And wherever is possible, try to use the limit operator so that you don't need to process that in the entire set of data. So often you are not interested in the entire output, but rather a sample or top results. In such cases, using limit can yield a much better performance. Okay. Now let me go on to.
Siva,
Yes, Anand.
a couple of things. These performance performance tuning will be recognized by MapReduce, MR according.
Yes, accordingly. See,
Okay.
here, if you are filtering these many records means you have reduced the record count that gets transferred through map and reduce phases in the background, right? So let's say if you don't filter this c dot t equal to 1 in the beginning, if you have 1,000 records. So all the 1,000 records should go through the map and reduce phases in the join and group by statements. So this join means what? In the background, it runs the map reduce job only.
Okay.
And group, so whatever you do, this group by or all these things will get executed through map reduce jobs in the background. Okay.
So,
If you reduce the record count in the beginning itself, then there will be a less record count. Let's say if you have 10,000 records and with this criteria only there are 100 records, then only 100 records moving through the map and reduce phases, your results will come faster instead of moving the 10,000 records to map and reduce phase. And finally, anyway, you need this condition, only these type of records. Okay, so this depends on the scenario. So what you are using and based on the script. Let's say if this is my requirement, I can rewrite this way more efficiently.
So Siva, the follow-up question to this is, like in what scenarios we use pig against the earlier data loading we saw, probably directly using our, when we were using the HDFS commands, you were explaining the whole architecture, right? You were explaining the name node and that stuff, right?
Yeah.
And so where does this pig come into, right? That's what I'm a little bit lost.
Okay. I think you missed that first day, first slide, I think, pig architecture. Pig is not part of your distributed architecture. Like, see, it's not part in the sense, it's a client software. It's a client tool. It just needs to be available on your machine from where you are running. So that's what I was telling, like if you have 20 node cluster, and one will be master in HDFS and one will be master in MapReduce, in Yarn, let's assume.
Okay.
So with respect to HDFS, on 19 nodes, data node services will be running. And again, on the same 19 nodes, node manager services will be running with respect to Yarn. But
correct.
If you observe pig will not be running in any machine.
Oh, it will be only on the client part, right?
If you have the client machine, 21st machine, which acts like a edge node, if it is an edge node, there you will install your pig and just pig grunt shell. So till here only it's a pig, like.
I see.
Okay, so till I submit the command, till there only it's pig engine. So in the background, you have seen this. It's creating a jar and submitting it to Yarn.
Correct. You showed the other.
Yep. Instead of you writing the jar, MapReduce program and creating a jar, it is creating that jar for you. Somewhere you can see it's connecting to the resource manager, submitting that. So it's pretty same from here onwards. It's under Yarn.
and then the yarn takes over and it writes to the multiple nodes and replication of that data.
Correct.
That is all taken care by yarn. Okay, okay. The pig has nothing to do with that.
Yep, pig has nothing to do.
Okay. Because when you say data load, that is where the confusion was. I thought that the data load itself is taken and it writes to HDFS, but no, it just executes that jar file.
Pig engine, loading into pig engine, or so when I say load statement, it will do the pig's temporary workspace.
Okay. And from that workspace, then that will be taken over by the MapReduce and all the stuff.
Yeah.
So the Hadoop architecture.
Yes.
I have a basic question here, corresponding to what you explained.
Yes.
It could be very, very basic actually. So let's say, on the edge node, the big is on the edge node, but we might have 10 developers. So does all that 10 developers additional pig engine, or just have a shell?
Yeah, they don't need to have in every user. You can install it at root level.
Yeah.
Add that into user bin directories. It's like same your sh command or same your pwd command. It need not to be installed for each and every user separately, right? So that's the beauty of multi-user support of your Linux operating systems. If you create 10 accounts, all the 10 accounts can use the commands that are present in user bin or just bin or whatever the...
It's part of the ACL thing, right? Okay, got it. Yeah, I forgot that, yeah. Thanks.
So essentially, Siva, basically pig is pre-massaging of data and staging and making sure.
Yep.
Okay.
It's a pre-massaging or a data cleansing tool.
Yeah.
It's just
so that,
even if you see all of the commands, they are useful for checking the bad records, identifying the null records, and filtering out some records, only the criteria matched records into output, and just format one form to another form. You'll see basic transformations. That's why we can also call pig as a ETL tool, one of the ETL tool.
Correct.
You load a data from HDFS file and you do some transformations, basic massaging and basic cleansing, data cleansing, and then you load it back to your target HDFS location.
But you are also using pig for querying the data and also using for metrics, right?
Yeah. You can use for kind of do aggregations and generate report. Comma separated or any flat files you can.
One last thing before I let you go on this one. So if I want to source existing Hadoop HDFS files, I can join them using pig. I can call them in the pig. I can join them and I can write it back, right? To the HDFS.
Obviously, that's what these two statements are for that only. This is for that only.
Because when it says pig storage, that is what I got confused. What is this pig storage?
See, this is the function name, that's it. You should not treat this as a separate storage layer or storage mechanism. It is just a class name or the function name you should take, which is used to load, which is used to read your HDFS file into pig's temporary workspace.
So it's a temp space. It's a temp space.
It's a temp space. That's it.
Okay. Like a processing place. Okay, fair enough.
Okay. Yep.
Thank you.
Yeah. So filter early, dropping nulls, all these things make sense, right? Join optimization. So use the limit wherever you don't need the complete list of data. And when you are interested in the distinct values, the unique values, always prefer distinct than group by and generating the group. So if you want to get the unique names, so one way is that you can group by name and for each C, generate group, only generate group. This will also give us the unique names, but this is relatively slower. So the preferred method is use the distinct you can get the distinct values. Next, the replicated joins. These are suggested when you have, this is similar to your distributed caching mechanism in MapReduce. If you have one big table and one small table, so you can specify this using replicated join big by B1. And so this is reverse to regular join. In regular join, we'll specify the smaller tables on left side and larger tables on right side. But in replicated joins, the bigger table on left side, from there onwards, immediately after the bigger table, start with the smallest table. This is the tiniest. If I am joining three tables, big by B1, which is the biggest one, and tiny by T1, which is the smallest one. And the next smaller one starts in the sequence. Tiny by T1, mini by M1. And if I have the next max or the less bigger one. Okay. If I have 10,000 records in this, it will come here. If it is just 100 records, if it is just 1,000 records. If you have 5,000 records, then it will come after this. Okay. So using replicated, just specifying this, it loads the small tables into distributed cache, and from there it joins them. So it improves your performance. Okay. And this is the topic that you were asking, Satish, okay, last week. Skewed joins. So skewed joins, it's not a separate join type, like where inner join or outer join type. It will not come under that. So if you are performing a join and if there are similar key values, like, so with one key itself, let's say if you are joining by country name, okay, two tables, and suppose for larger countries like, so India or something, you will find more records, and similar key values should be fed into one single reducer, right? So that is the concept of your partition. So if you have for a single key, if you have half of the records, then one reducer will be processing the half of the load, and remaining all the reducers will be processing the remaining half of the load. Then obviously that reducer is going to take a lot of time. So this imbalance of these records, okay, these load imbalances will swamp any of the parallelism gains. Okay, so this is called that is, the data is sufficiently skewed. If the underlying data is sufficiently skewed, this load imbalances will swamp any of them. In this case, we use the skewed joins. If you specify using skewed, then in the underlying backend, so it tries to reduce that imbalance, and it uses it kind of some optimization techniques to achieve the performance there. Instead of one reducer being processing that all the key values, it uses multiple reducers and does some kind of on the aggregated results, and I think it does one more layer of processing or something similar to that. Okay, even in this, as a programmer, it's just a matter of using Skewed, specifying this class. That's it. Okay. And merge joins is another join type. So when you have both the inputs are already sorted on the join key. So in that case, you can use this merge joins. So already in this relation A, if your records are already sorted by A1, and in this table B, if your records are sorted by B1, table C records are sorted by C1, then you can specify the merge joins, and these run even more faster. Okay, so these are some of the optimization techniques, the BigQuery optimization techniques. So with this, we discussed how to load datasets into big temp space and how to perform transformations. We have seen on all string functions and datetime functions, math functions. So relational operators, and we have also discussed about the user-defined functions and how to load the custom file formats, and so how to tune your performance tuning of your BigQueries. So with this, we'll wrap up the big session, and tomorrow we'll start with the Hive concepts. Any questions?
Nope. Thanks.
Well, not related to this, but I was planning for overall, there is a 4th of July weekend, and is there a way we can have a break on that weekend?
Weekend is a break only, right, for you?
No, like 4, 5, right? So July 4th is a major holiday.
Oh, okay.
Yeah, that weekend, the kids, everything, we're getting holiday after a while.
We can plan, not a problem. But you have to compensate on the other day.
That'll be fine, if it is okay with everybody.
Yep.
Yeah, so those only.
We can give a break, but you should accommodate 2 more hours in the same week, so that so somewhere on Tuesday, Wednesday or Thursday, we should spend 2 more extra hours.
That'll be great.
Okay.
You can poll and let everybody know about it. So.
Yep.
You want me to initiate that in our group?
Yep, you can initiate that in our WhatsApp group.
Okay.
Yes.
Okay. Can you include me in the WhatsApp? I don't think I'm in any of those WhatsApp group, I think.
You're not there?
No, I'm not there. Sorry.
Let me. Yeah, I will add.
Sure.
Okay. So, any more questions? If not, we can wind up the call, wind up the meeting. Okay. So thanks everyone. I'm giving you 8 minutes today to you. Back. Bye-bye.